Hello everyone. So welcome to this first live session for the course Computational Fluid Dynamics for Incompressible Fluid Flow. So if you have any queries, you please post it here. So please switch on that. So we have received few questions. These are the two questions related to this course content I will discuss. The first question is, why is higher stencil size more computationally intensive? So you can see that if you use higher stencil size, that means you are using more number of points which are unknown. So obviously when you will see the discretized equation, number of unknowns will increase. So when you will solve this set of algebraic equation, the matrix size will be more and your computational time will be more. The next question, I am a total beginner for CFD. How should I practice during course period so to get more grip over the concepts? Is coding language most necessary for CFD? So obviously you can see that to learn basic CFD you should do some small coding for solving simple problems like steady state heat conduction equation or unsteady heat conduction equation. Even you can solve this convective diffusive equation. So these are very simple to code, and you will know how to write a code as well as the which way you have discretized those you are doing in pen and paper. But when you will write and you will get results, then you will see that how these algorithms work. So for that reason you can use any coding language which you are comfortable, maybe in Fortran, C++. So even if you use some commercial software like ANSYS Fluent or open foam, these are open source software. Then you have console. So in those also you need to write some user defined function, and that time you need to write some code. So it is advisable while learning CFD you should at least write some simple codes for better understanding. So if you have any questions, you please post it here. We'll discuss. So this is a very basic course of CFD, and you can learn all the algorithms, different types of convective schemes, how the equations are discretized using finite difference method and finite volume method. So obviously, this will give actually you to understand means what is CFD and how means you can discretize using different schemes, what type of error you will get, and also what type of accuracy you want. So when you are using some commercial software, then you will be knowing that what is happening inside. So if you are not getting results, what are the expected problems that you can understand, and accordingly you can change the parameters. One question is that please share any of the software in the Swarm portal or Google group. Say software, commercial software cannot be shared, right? So because you need to purchase those software, some trial version you can get from their site. So ANSYS Fluent, one of the means most popular CFD software. Some open source software already I have told in the first class that you have this open form. So open form, it is open source software. You can download the source code, and also you can modify as per your need. Another software for solving multi-phase flow is Basilisk. So that is also open source software. You can download and you can solve two-phase problems. So if you type in Google, you will get this type of software site, and from there, as per your computer requirement, you will be able to download the software, and you can use it. Yes, I got this query in the discussion forum that some civil engineering students are there. When I actually developed this course, in my mind, it means only mechanical engineering and chemical engineering students were there. Mostly they solve these heat transfer problems. But anyway, if you are civil engineering, obviously it will be very difficult for you to understand the heat transfer, but fluid mechanics already you have studied. When means you will see the governing equations, obviously you will be able to understand what type of equation it is, and accordingly you will be able to discretize those equations. If you have any questions, you please put in the chat box. Do we get questions that require some coding to solve during our assignments? Uh, it is very difficult to check the coding assignments. So for that reason, I have not given any questions on the coding. But we have already discussed those in the lectures. So those equations, whatever I have shown the code, you can write on your own and you can practice, and also you can validate those results, okay, with the available results in literature, or you can have the analytical solutions. You can compare your numerical solutions with the analytical solution. One question is there: if we don't know the outlet condition for a CD duct, working as a diffuser, so how to simulate it only with inlet condition? What conditions to apply at outlet? So if you are dealing with incompressible fluid flow, obviously at outlet you need to specify either pressure boundary condition, or the if it is outflow, then you can put the velocity gradient as 0, and velocity gradient as 0, okay, normal gradient as 0. So when you are solving this incompressible fluid flow, obviously you need to give some boundary conditions. So without giving boundary condition, you will not be able to solve the problem, okay. But if it is as a elliptic type, parabolic type problem, let us say flow over a flat plate, so this boundary layer equations, if you want to solve boundary layer type equation, then obviously you can see that it is parabolic in nature, and you need to march in x direction. So that time you don't need to any outflow boundary condition, okay, because you will be calculating the values at any x location from the earlier location, okay. So you don't need any boundary condition, but depending on your problem, obviously you need to find what is the pressure boundary condition, or you can simply, if it is outflow, then you can give velocity, normal velocity gradient is 0. Another question: which coding language is useful for CFD? So any coding language you can use. So nowadays you can use C, C++, Fortran, or you can use also Python. Okay, so any coding language you can use for solving the this problem using writing the computer code. Research area related to CFD. So it is an open question. Okay, you have seen that CFD has vast application in different fields, not only limited to mechanical engineering. You can apply in chemical engineering, civil engineering, or any biomedical engineering as well. Okay, so means it depends on that in which research you are interested, then obviously you can think whether you can apply CFD or not. Regarding the assignments question and solution, you please wait for the solution to upload. Okay, so I have also got some question in the discussion forum. So I think this week those solutions will be updated. Then if you have any questions, then you please post in the discussion forum. We will discuss and we will reply. The next question is that please give some reference for solving higher order non-homogeneous PD set. I am not getting what you are asking. Are you asking that how to solve higher order non-homogeneous PD, or I am not getting? So means you are telling that every time we use second order differential equation, where is the means if you have any applications in more than second order means non-homogeneous differential equation, partial differential equation. Are you asking that? I'm not getting. I will discuss the next question. What is the role of CFD in ISRO and DRDO, and what kind of tools will be used by them in research? So obviously you can see in ISRO, DRDO, CFD application is there. Okay, so you can means already if you see in their site, all they are having their in-house code. Okay, in ISRO, DRDO, so they are having some in-house code. So they use those code to solve their problem, as well as maybe they will maybe using some commercial software. So that I do not know, but I know that they are having their in-house solver to solve their problems. Say, you know how to discretize the equation. I am just trying to answer this question. This engineering problem solved in more than second order PDEs. Some methods or books for solving higher order non-homogeneous PDE. So whatever equations we encountered till now in our engineering applications, we have seen that it is second order. And now you are asking that how can we solve a higher order means PD. So say non-homogeneous is not a problem because you are using numerical discretization to solve the partial differential equation. So non-homogeneous will not be the problem, but higher order will be the problem, because higher order you have seen that if you have a mixed derivative, how we have discretized the equation, and so many stencils are involved. So if you have obviously higher order PD, then based on the physics and also whether you need to use upwind, based on that you need to discretize that equation. So obviously you can see that whatever means techniques you have learned in this course, say to discretize any derivative, so similar method you have to adopt and discretize the higher order PD. Okay, so but I have not encountered till now any this application of this higher order PD, but mathematically obviously you can solve it. Yeah, I will check. If I get, I will just post it in the discussion forum. How to decide which solver will give good and more accurate results? Like example, simple, simpler, simplex, piso, coupled. How to decide which viscous model will give good turbulence prediction? K epsilon, K omega. Okay. So you can see that generally when we solve some problem, we try to get either spatially higher order accurate as well as temporarily higher order accurate scheme. So based on your need, say whether it is pure means a tangent problem or it is a steady state problem, so you will decide whether to use higher order temporal discretization or not. For spatial discretization, obviously you need to use higher order convection scheme so that you can get good results. Now it depends on the user, okay, who is writing the code or who is using the software to choose what type of accuracy he wants. Okay, so based on that he can decide. And regarding the other algorithm for solving the Navier-Stokes equations, I have already discussed in the class, but that is in the towards the last module. So simple, simpler, simplex, all will give same results. Okay, accuracy wise, these are same. Only the solution time will differ. Okay, so some may take more time to solve the problems. So based on your means total number of grids, and you can use any algorithm as you stated here. And similarly, like for turbulence model, so there are different, other than k epsilon, k omega, different models are there, SST model. So that again you have to see that whether flow separation is there or not, and whether how much means refinement you can do near to the wall. So based on that you need to choose uh, this turbulence model, k epsilon or k omega. Okay, so that you should have some theoretical understanding that where to use what this turbulence model, so that you can predict the results more accurately. Kindly provide some ideas for BTech project in CFD. So, as I told that you can solve different problems in CFD. So now you have to apply CFD to some solving some problem. Okay. So based on your interest, or if you have some inclination in some specific research area, you can search some journal papers, international journal papers, and you can first solve that known problem, okay, and compare your result with that paper to check whether you have correctly solved the problem using some commercial software. Now, if validation is done, then similar problem you can solve using the this software. Okay, so now need means I cannot say that which problem, because there are different applications are there, and based on your interest that you have to choose. Okay, say like some examples I will give. Say flow over a blob body. It is one of the most studied research problem. Now this blob body may be different kind, like it may be circular cylinder, it may be tapered cylinder, or it may be triangular cylinder, square cylinder. Okay, and you can extend it to two-dimensional or three-dimensional, and also it can be confined between two walls. So inside a channel you can place this blob body. So you can see that this is one of the research area, and means people have studied in past. Similarly, if you can see that natural convection problem. Okay, so if you have an enclosure and differentially heated, vertical walls are differentially heated, and horizontal walls are adiabatic, then obviously there will be natural convection. If the temperature difference is low, then using Gaussian approximation you can solve the governing equations. And you can see now this is also one problem means researchers have studied, and now you can have different variations, like you can put some heater in the side walls, or your side walls may be wavy, or you can put some blob body inside this enclosure. So that way you can see that those are having some applications, obviously, like we are talking about the flow over blob body. So you can see from civil engineering point of view, let us say you have a bridge and the pillar may be circular or elliptical in shape. So now when the fluid flow will occur over it, what is the drag force, lift force, or moment acting on this pillar? So those can be studied. Similar way, say long building, okay, 100-storied building, 50-storied building, so this can be also seen as a blob body. So these are some applications you can think of, and just you see some journal papers, then you will get more idea of what problems to solve using CFD. So any sources on how to implement the numerical methods into codes and solve them. So I have already solved a few problems in this lecture, like elliptic problem. That means that is just get square psi is equal to 0. So you can solve this problem. Then parabolic problem I have considered, unsteady heat conduction equation. Then also we have solved this stream function vorticity equation. Okay, so that is a convective diffusive equation. So these three equations we have solved in this lecture, and I have shown the code also. Okay, so you can see and apply on your own. You can use any means language. I have used C, but you can use any language. And you, when you are writing some code, you have to see that which optimum way you can write. Okay, unnecessary you should not use more loops, so that it will take more time for the solution. Okay, so once you start writing, then you will get some idea that how to write a optimum code so that it will take less time. Okay. One question is, should I use inbuilt softwares or write my own code initially? Say, I would suggest to write your own code using means some computer language. Say, you can use MATLAB, okay, but already inbuilt function will be there, and that you can use. So better that if you want to learn these numerical methods, it is better to write your own solver. Okay, small code, once you write, you will get the confident, then you can solve this convective diffusive equation. And once you get the confidence, then you can solve full Navier-Stokes equations. Okay, where you need to solve, along with this momentum equation, you need to solve a pressure equation or pressure correction equation. So it is more difficult to solve, but once you get the confident, you can attempt those means you can write that code. Okay, so when I teach this course here, I give these assignments, and they need to show the computer code also, just running that, and means in the computer lab. So this way we teach, but here obviously it is difficult, but as I have already shown this code, means you should be motivated to write your own code. Okay. In ANSYS, I am giving only one boundary condition, either pressure or velocity. How software predict another boundary conditions? Can you please explain how? I didn't know. I couldn't understand how software predict another boundary conditions. Okay, so you are telling that you are giving pressure if at the outlet, then how it understand the velocity boundary condition, and if I give the velocity boundary condition, how it understand the pressure boundary condition. I think this is your question, right? Okay, so if you see that once you give at the outlet outflow boundary conditions, okay, outflow boundary conditions, then automatically this velocity gradient will become 0. Okay, so automatically this velocity gradient will be 0, and once you give the pressure 0, then the velocities are actually calculated using some average, from the average mass flow rate at the outlet. So what it does, say, obviously the it should be inflow should be equal to outflow, right? So net flow from the surface should be 0. This is from continuity equation. So they calculate the net outflow outside, then maybe due to numerical errors there will be some difference. Okay, and that they actually implement in the velocity boundary conditions. Okay, so this is actually inbuilt, it is done, the code is already written inside the fluid. Okay, so once you provide one boundary condition, automatically it calculates on its own. Okay, so for more actually you can search in ANSYS Fluent, you will get it. Okay. How to predict good y plus? Say, obviously, if you use k epsilon method and if you can find that in trial and error method, this y plus if it is less than 5, okay, because once you solve, then only you will be able to find what is the y plus value, right, based on the solution A. So then accordingly you can use more finer mesh near to the wall so that your y plus value is less than 5. Then obviously near wall turbulence you can means better way you can predict. Every time, is it mandatory to compare computational results with experimental results, or why it requires? Not always. Say if it is a simple problem and if you have analytical solution, then obviously you can compare with the analytical solution. And say when you are solving a new problem, then obviously you do not know the outcome of the results, right? So if you can get some similar type problem, so that you can solve that problem and compare that results with the available experimental or available numerical results. Say someone has already solved that type of problem, then you can actually compare with the numerical results. It is not always mandatory that you need to compare with the experimental results. And when you are solving a new problem, obviously to know the accuracy of your solution, you will see that people ask for whether you have compared with the experimental results, okay, because there may be different errors involved while solving it numerically. Okay, so I will give some examples. Say let us say you want to solve a block body problem, say flow over let us say circular cylinder. Okay, so obviously if you don't have the results of flow over circular cylinder, although you have, you can solve some similar problem. Let us say you know that flow over square cylinder, you have the results, so you can compare with the available numerical results of this flow over square cylinder, and you can compare that, you can solve that problem and compare the results with that. Then you can solve the flow over circular cylinder, because it is similar problem, flow over a block body. And if it is confined, then confined some problem you can choose and compare the results. So another question, since finite volume method based on conservation of energy, uh, why are we worried for mesh quality? How solution dependent on cell volume when inflow and outflow is basis of my solver solution? No, say obviously the you are conserving either mass or momentum or energy in a particular cell using finite volume method, so obviously it will be conserved. But when you are discretizing it depends on the cell volume. Okay, so you can see that in discretization, when the coefficients are involved, the cell volume is there. So and you have to see the physics of the problems, right? Say if flow is occurring, so when it is passing, say per unit time, it should not pass a single volume. If it pass, then obviously you will lose some physics of the problem. Okay, so for that reason you need that cell volume or the grid size. Okay, so that is known as grid independent study. So when you are actually refining the mesh, you have to check whether your results are getting changed or not. If it is changing, that means that result is not grid independent, because when you further refine the mesh, your results should not change. So that is the grid refined, means grid independent solution. Okay, and once you change the grid size, delta x, delta y, delta z, obviously your cell volume will change, right? So when you are solving a problem, you have to check whether it is grid independent solution or not, just refining the mesh further. Okay, once you see that there is very small change between two grid size, then you can say that okay, it is a grid independent solution. Ideally you should actually increase the number of size double. Okay, so if you are using 10 by 10, then you should use 20 by 20, then 40 by 40. Then that way you have to see whether your solution is not getting changed with the further grid refinement. Sir, can you give some insight on CFD application related to energy engineering? So in energy engineering, direct application is that in solar energy. Okay, so if you are heating some means liquid through a pipe or means channel, then obviously you can see that you have boundary conditions. You can also solve some radiative transfer equation to take into account the radiation and also fluid flow inside the channel or tube. Okay, so that heat transfer is also involved. Other way you can solve, say now you have a different type of batteries, right? So these energy storage devices, that also you can numerically model. So say electrochemistry is involved, so those equations you can discretize and you can solve using CFD, right? So you can see that nowadays this lithium ion battery or the redox flow battery, so all these you can numerically solve using CFD. Please explain more about the characteristics, especially domain of dependence and domain of influence, and their why they are important. Say we didn't discuss more, and I don't want to discuss more of domain of dependence and domain of influence. It is mostly related to hyperbolic equations. Okay, and we didn't actually solve for hyperbolic equations here because we are solving mostly the means incompressible fluid flow. For compressible fluid flow, when the shocks you want to capture, then obviously it is very important that domain of dependence and domain of influence. Obviously, say if you are at a particular point, okay, whether that solution, okay, when it is further you are going ahead, how it will actually reflect. Okay, so those I will not discuss here because mostly it is relevant to the compressible fluid flow. I mean to quality of mesh like skewness, etc. How the affect my solution because inflow and outflow is basis of finite volume method. Say ideally 70% of your total time for solving a problem you should give to grid generation, because grid generation is very important to get a good solution. Okay, now very good mesh is that if it is orthogonal mesh. Okay, in any coordinate. So if means two cell centers if you join and that line if it is parallel to the face normal, then it is orthogonal grid. So in orthogonal grid you will get means very good solutions, but if it is a skewed mesh, okay, then whatever way I have shown the discretization of diffusion term, there will be some additional term, because you can see that in when the skewness is there in the grid, then it might happen that when you are joining the two cell centers, it may not be parallel to the phase center. So due to that, there will be some additional term coming to the discretization of this diffusion term, and that is known as cross diffusion. So normal diffusion already you have calculated when the grid is orthogonal, and another additional term will come, and that too you need to find, because when the cross diffusion you will calculate, you will see that it depends on the value itself. Okay, there will be some gradient of the variable and the variable you are solving, so both way it is coupled, so you need to solve it iteratively. Okay, so obviously you have to see that means it should not be very skewed grid. Okay, and as per as means you can, if you can means generate a orthogonal mesh in a particular region, so you can means you should generate. Actually if you divide, if it is a complicated domain, then you divide into subdomains or subzones, and you generate the grid in zone wise, and you connect through the interface, so that you can generate a very good mesh, and with a less skewness factor. Okay, so you have to be means you have to give more time in grid generation, because your whole solution will depends on how good your grid is. So we'll wait for another 5 minutes. So if you have any questions, then we'll answer. You please post your queries in the chat box. So Niladri has written that he has done many projects, good, very good. But I think you have used some commercial software, maybe solving this type of problem, or you have means used your own code. I do not know. whatever problem you are telling, mostly it seems that you have used some commercial software. So one another question, is the course sufficient to solve real life heat transfer problems? Say this is a basic CFD course. You will get obviously some idea, and means if you want to learn more, then you have to means study some books. Okay. So if you want to solve some problem, it is always advisable that related some journal papers or related some topic you read from the means book. Okay, so say I have taught only basic things. Okay, but if you want to learn more, you need to study some book and relevant topic. Say all the topics you will not get in a single book, so relevant topic you can see that in which book it is good, and you can means read. And nowadays you can search journal papers online. Okay, and which problem you are interested, you can search in internet, and you can see that which way they have solved, what are the means advanced technique they have used, and accordingly you can use it. Okay. Can we choose non-circular sections of pipe in heating or water and design for better heat transfer coefficient? Say that is a research topic, so you can use CFD, check the Nusselt number or heat transfer coefficient for different configuration, and you can see that whether your design is giving better performance in terms of heat transfer or not. Okay, and non-circular sections anyway you will be able to solve using commercial software. Okay. So regarding internship in our department at IIT Guwahati, there will be call from the department and it will be posted in the website, department website. And based on this call, you need to apply. Then means concerned committee will select the students. Uh, then we can choose a student for the internship in our means department. So that is the procedure. The advertisement will come in the month of March. Okay, early March. So I have already discussed about the internship. Okay, so there is some procedure in our department that you have to follow. If you get selected, then obviously means you can do internship. Okay, so if there are no further technical questions, then we'll stop here today. If you have any other questions, you please post in discussion forum. We will answer regularly your queries in the discussion forum. Okay. So thank you again. We'll meet in the means for the second live session. Thank you.